activity number 3, given the first problem, find the head loss in 100 feet of 3 feet diameter welded steel pipe carrying 15 feet cube per second of water at 60 degrees Fahrenheit. So given the 3 formulas that we'll be using in finding the head loss, first one is the Darcy-Weisbach. Given the value of F, which is equal to 0.0135. The given are the length, which is 100 feet, the diameter, which is 3 feet, and the discharge, which is equivalent to 15 cubic feet per second, and then a temperature, which is equal to 60 degrees Fahrenheit. So we'll have the formula of Darcy-Weisbach. So the formula is HF is equals to 0.0826 multiplied by F times L times Q squared over the diameter raised to 5. So substituting the values, 0.0826 multiplied by 0.0135 times 100 feet, which is the length, times 15 cubic feet per second squared over 3 feet raised to the 5. So is equals to 0.103 feet. Then letter B, using Manning's formula in solving the head loss, the formula is HF is equals to 10.29 N raised to 2 multiplied by the length times the discharge squared over the diameter raised to 16 over 3. And then substituting again the values, 10.29 multiplied by 0.012 squared times the length, which is 100, times the discharge, 15 cubic feet per second squared over 3 raised to 16 over 3. The answer is 0.095 feet. Letter C, using the Hazen-Williams formula in finding the head loss, HF is equals to 10.64 length times the discharge raised to 1.85 over the diameter raised to 4.87 times C, which is given the value of C, which is 120 raised to 1.85, is equals to 10.64 times 100 feet, which is the length, times 15 feet cubic feet over second raised to 1.85, divided by 3 feet raised to 4.87 times 120 raised to 1.85, and the answer is 0.108 feet. And these are the values of head loss using the 3 formulas given. Number 2, fluid flows through a 10 mm diameter tube at a Reynolds number of 1,800. The head loss is 30 meters in a 120 meter length of tubing. Calculate the discharge. So the given are the diameter, which is 10 mm, the Reynolds number, which is 1,800, the head loss, which is 30 meters, and then the length is 120. Required is the discharge in liters per minute. So solution, using the formula F is equals to 64 over RE, we'll find the value for F using RE and the value of RE. So substituting the values, 64 over 1,800 is equals to 8 over 225. And then using Darcy-Weisbach formula, we will be able to find the value for Q. So yan, walang ibang factor na given, so HF is equals to HL. So is equals to 0.0826 times F times L times Q squared over diameter raised to 5. So substituting the values, 30 is equals to 0.0826 times 8 over 225, which is the value of F, times 120, the length, and Q squared over 10 over 1,000 raised to 5. So yan, manipulating the formula, we'll have Q is equals to the square root of 30 times 10 over 1,000 raised to 5 over 0.0826 times 8 over 225 times 120, and then the answer multiplied by 1,000 liters over 1 cubic meter. So, i-convert natin yung convert natin yung cubic meter dito. So, makancel yun into liters. And then, over seconds, convert natin in minute. So, and cancel. The answer multiplied by 1,000 liters is to 1 cubic meter times 60 seconds equivalent to 1 minute. So, yung sagot is 5.536 liters per minute, and that's our final answer. Then number 3. A pump of 80% efficient delivers heavy oil which has a density of 912 kilogram per cubic meter, and then kinematic viscosity which is equal to 2.05 times 10 raised to 4 meters squared over seconds through 500 meter of 5 centimeter diameter pipe to a storage tank whose oil level is 3 meter higher than that of the supply tank for a flow of 4 liters per second. Determine the input power of the pump. So, the given are the density, which is 912 kilogram over cubic meter, the length, which is 500 meters, the diameter, which is 5 centimeter, the change in elevation, which is 3 meters, which is the value for the difference in height of the two storage tank, and then the discharge, which is 4 liters per second. So, solution. So, in getting the value of Pi, we will first start in finding the value of the velocity and other factors. So, getting the specific weight of oil, 912 kilogram over cubic meter times 9.81, which is the value of gravity. So, we'll have 8946.72 newtons per cubic meter. The next is our velocity, which is given velocity is equals to the discharge over the area. Substituting the values, 4 over 1000 is equals to pi diameter squared over 4, which the value of the diameter is 0.05. So we'll have velocity is equals to 2.037 meter per second. Then after getting the value of the velocity, we will now substitute this value to the formula of Re. So the Reynolds number is equals to the velocity times the discharge over the kinematic viscosity. Substituting the values again, 2.037 multiplied by 0.05 over 2.05 times 10 raised to negative 4. And then we'll have the value for Reynolds number, which is equals to 496.829. Then after getting the value for the Reynolds number, we will find the value of F using the given formula 64 over Re. So manipulating the substituting the values of Re, 64 over 496.829, we'll have F is equals to 0.129. And knowing that we can solve for the value of P using the formula, power is equals to the discharge multiplied by the specific weight times the L, which is the difference, the height difference. So, knowing that L is the difference in elevation of the two storage tank, plus F multiplied by the length over the diameter times velocity squared over 2g plus velocity squared over 2g. So, substituting the values again, P is equals to 4 over 1000 times 8946.72 multiplied by 3 plus 0.129 multiplied by 500 over 0.05 times 2.037 squared over 2 times 9.81 plus 2.037 squared over 2 times 9.81. So calculating the values, we'll have the value of P, which is equal to power, is equals to 9871.636 watts. And then for, we'll have the value. So in getting the value of Pi, we will have the formula Pi is equals to the power over the pump efficiency, which is equivalent to 80%. So we substitute 80%, 0.8, 9871.636 watts over 0.8, and the answer is 12339.545 watts. Yun. Or 12.34 kilowatts. So we'll divide 12,339 into 1,000, we'll have 12.34 kilowatts. And that's our final answer.